Got a great example here for solving a triangle. And when we say solve a triangle, we mean find all the missing sides and angles. We want to provide all three angles, and we want to provide all three sides. Oftentimes you'll be given three of those. And if we read this, we've got triangle DEF. E is 25, D is 16. The measure of angle D is 90 degrees. So let's see if we can draw a fairly accurate triangle. It doesn't have to be perfect. But we do want to try to get something that's close here so that our mind can wrap itself around this problem. Let's make this D here. We know D is 90, so we got a right angle. And then E would make sense here. That looks to be about 25 degrees. And then we don't know this angle, but that'll be angle F, and we're going to have to find that one. And then we're also told that D here, the hypotenuse of this right triangle, is 16. One thing when I start these problem solving triangles I like to ask myself to begin with is, do I have a right triangle? If I do, then I can use the Pythagorean theorem. I can use my regular sine, cosine, and tangent. The law of sines and law of cosines will work for sure, but it will kind of complicate yourself a little bit. If you prefer that, go ahead. But I think it's very, very useful to identify that this is a right triangle so that we can use those other relationships, and we can also use those to kind of check. Alright, so let's work on angle F here. I think that's going to be the easiest one for us to solve for here. So we know that these two angles are complementary. We have to find another angle. When we add it to 25, we get 90 degrees. And I think that's going to be 65. So the measure of angle F is 65 degrees. And you want to state that off to the right and then also, or wherever. And then also try to draw that on your diagram. Right now, as far as the Pythagorean goes, we're kind of stuck. We've got this side E down here, and then we've got F, and we know that E squared plus F squared is 16 squared, which is a great thing to know, but we need to know either F or E so we could solve for the other one. So right now, it's going to be the easiest thing to do is going to be to solve some kind of trigonometric ratio. It doesn't really matter which one you set up, except you need to use a trig ratio that has a value in it. So for instance, we got to use a trig ratio here that has 16 as a value in it, the hypotenuse. So we wouldn't want to use tangent here. That would be opposite over adjacent, and so we'd have F over E or E over F, depending which angle you look at. And I always like to look at the angle here that we're given. You know, what if you made a mistake and wrote 55 degrees down there? That's an easy one to make. Or another easy one is 75, right? Maybe you've done that. You've seen the 2 here and you said, hey, they're complementary, it's got to be a 7. And then 5 plus 5 is, we'll make it a 0. That'll add to 10, so we're good to go. That happens, and you'd have a wrong answer here. So if you use a wrong angle, you're going to get a wrong side value. So try to go back to the original angle measure if you're given one. So let's look at 25 degrees. If we want to solve for side E maybe, this is the opposite, and then we're going to need to use the hypotenuse. So opposite and hypotenuse is totally the sine. So let's set up a quick little equation. The sine of 25 degrees is equal to the opposite over the hypotenuse. We'll multiply by 16 on each side, and we'll find that E will be 16 times the sine of 25 degrees. Alright, and we can't figure out this one exactly, so we're going to do, let's see, 16, and then sine of 25, and then make sure you're in degree mode. That's going to be important. So we can come back here, hit enter, and we've got E to be approximately 6.8. We're not given any units, and we're actually not told to round to a specific value. So make sure to ask if you're wondering, you know, especially on a quiz or a test, like, hey, Mr. V, what do you want us to round to? So we'll go to the nearest tenth for this one. And without any context, it's kind of hard to figure out what degree of precision we need, but that'll work. And then we can also set up another ratio, and this time, oops, I think we're going to do cosine of 25 degrees. We need to solve for this F over here. And so that's the adjacent side, and then we can use the hypotenuse here. Same thing, multiply by 16. And so F will be 16 cosine of 25. There's your exact value. Can't really do much with that, but we could type it in and get an approximate. Especially if this was a real life problem, you're probably going to want to find some value that would work there in a usable fashion. So it's about 14.5. Use the approximate symbol here, about 14.5. And one thing that I like to do is, and you could have done this before, but I like to check my work by seeing if this makes sense. Take a look at the 90-degree angle and the hypotenuse. It's going to be the largest side. That's true, so we're good there. You ever end up with like anything more than 16 in this case over here or over here, you just might have made a mistake somewhere. So go back through your work and double check. Also, one thing we know is that a side that's opposite of the angle will be correspondingly larger or smaller depending on the size of the angle. So the smallest angle in this right triangle is 25 degrees. Opposite of that side, there should be the smallest side length. So 6.8 is lower than each one of these. 65 degrees is a little bigger than 25 but smaller than 90, so its opposite side should fit right in between somewhere of 6.8 and 16, and that's true. We could also check our work by taking our rounded values, 6.8 squared and adding 14.5 squared, and hoping that that's something close to 16 squared. You can see here we got 256 and a little, and then 256. These are very close. They're only 0.49 off of each other, and the reason for that is because we rounded. So if these are very, very close, it's a good bet that you've done it correctly. So lots of different ways to check your work. You could even set up other ratios with sine or cosine or tangent, but I think at this point we're pretty confident of what we've found. So we've got the measure of angle F, side E, and side F. And those are the three parts of the triangle that we didn't have before.